Greetings, class. This video is the last of the 3 videos on descriptive statistics. When we describe a data set, our primary focus is on obtaining measures of central tendency, measures of variation, and graphical displays of the distribution of variables. The topic of this video is choosing appropriate graphs to show the shape of a distribution. A graph is a pictorial representation of data. The most commonly used graphs include bar charts, pie charts, histograms, frequency polygons, and box plots. Let's begin with the bar chart. A bar chart is used to illustrate the distribution of qualitative variables. The number of bars corresponds to the number of values of the variable, so each bar represents an individual category. The height of the bars indicates either the frequency or relative frequency of that category. Importantly, the bars should be separated by spaces to reflect the lack of continuity among categories. In my example, the 3 bars represent the 3 categories of sex. Their heights shows frequencies of 30, 29, and 1 for female, male, and non-binary, respectively. A pie chart offers another way to illustrate the distribution of qualitative variables. The number of slices corresponds to the number of categories, and the size of each slice represents the count or percentage of observations in that category. That's why the slice for the non-binary category appears so small. Histograms are used to illustrate the distribution of quantitative variables. The easiest way to understand a histogram is to view it as a graphical transformation of a frequency table. The values are divided into equal-sized intervals, with boundaries marked along the horizontal axis. A histogram resembles a bar chart, but the bars are not separated by spaces, indicating that the distribution represents a continuous variable. In my example, the IQ scores are divided into 10 intervals of width 10. We see 17 individuals with scores between 100 and 110, and 2 individuals with scores above 140. A frequency polygon can be regarded as a transformation of a histogram. Starting with the histogram of IQ scores, if we mark the midpoint of each interval at the top of its bar, and then connect these midpoints with straight lines, we obtain a frequency polygon. The assumption is that scores within each interval can be represented by its midpoint. The smaller the interval width, the smoother the frequency polygon becomes. The vertical distance from a point on the polygon to the x-axis represents the relative frequency at that value. The next type of graph is the box plot. Unlike histograms or bar charts, box plots do not display frequency distributions directly. Instead, they highlight key percentiles. The median, which is 50th percentile, is shown as a central line within a box bounded by the 25th and 75th percentiles. The minimum and maximum values are marked with whiskers extending below or above the box when the box plots are presented vertically. Boxplots are especially useful for comparing score distributions across different groups on the same variable. In addition to graph types, we also use certain terms to describe distribution shapes. A uniform or rectangular distribution occurs when all values are equally frequent. For example, rolling a fair die many times, each side will have similar frequency and the values show a uniform distribution. A normal distribution, which you might know as normal curve, is symmetric about the mean and shaped like a classic bell curve. When a distribution is not symmetric, it's skewed. In a positively skewed distribution, most scores clustered at the lower end, with a tail on the right. In a negatively skewed distribution, most scores clustered at the higher end, with a tail on the left. Another feature of distribution shape is kurtosis, which measures peakedness. Distributions with sharp peaks are called leptokurtic. Flatter distributions are platykurtic, and those with moderate peaks are mesokurtic. To summarize, bar charts and pie charts are used for qualitative variables. Histograms, frequency polygons, and box plots are used for quantitative variables. In this table, I provide a summary of proper measures of central tendency, variation, and distribution shape for the 4 types variables. Hope it helps.